Here we go. Natural log. Okay? So you guys should have that in your notes. All right? And we move on to what is a natural log. We've talked about this. Natural log of E would be log base E of E. If you want to think, also you could think, if that makes it a little confusing, say the natural log of X would be log base E of X. Okay? So make sure that's in your notes. All natural log is, it's just assigning the base E to your log. Okay, so they mean the same thing. All right? Okay, so if you think of it that way, log base E can be thought of as ln. All right, they mean exactly the same thing. All right, so on your calculator, I want you, or excuse me, without your calculator, I want you to evaluate what you think these will be. You get about 1 minute to talk about it, work on it with your group there. So in this case, we get log base E of E, right?
Yep.
Natural log means log base E of E equals X. Now, anytime you're taking the log of something that's your base, what do you get?
1.
Yeah, E to the first is 1. And you could think of it, if you wanted to, you write it exponentially. That would mean E to the X is equal to E, which means X equals 1. It has to be the first power. Okay? Please let me know if I go off the screen here. I'm not used to sitting here teaching this. Okay? So natural log of X, yeah?
Is the base, when you wrote log E, is that E supposed to be a base or next?
Yeah, that's base E. Yep. Base E. Okay? Natural log of X equals 0. What's X?
1.
Yeah. Elizabeth. Yeah, 1. So let's check it. So we have, that's log base E of X, okay, equals 0. So you're saying E, if you write it exponentially, E to the 0 power equals X. So that would, anything to the 0 is 1. All right. So those are two properties you want to write down, just like the ones we started with earlier on. Okay? Get those copied into your notes. Your textbook now, I want you to study example 1 and answer questions 5 and 6. All right? Study example 1 and answer questions 5 and 6 in your text. Okay, use your graphing calculator. You get about 2-3 minutes to work on it with your groupies. Go for it. You started out with that equation, 8e to the 2x equals 20. Okay? The first thing to do is, if you're going to do this on your calculator, is to set each of these parts equal to y. So set that equal to y and set that equal to y. We'll call this y sub 1 and y sub 2. So you have y sub 1 equals 8e to the 2x and y sub 2 equals 20. Okay? So yeah, Megan?
Where did you get that equation?
Where did I get the equation? That's example 1. That's example 1, number 5 and 6 there. What page is that? 337. Okay. Very good. So 80. So if we graph those, the first part there, that's what you come up with. Okay. How many got that? How many graphed it? Uh-oh. Hey, why don't we graph that? Graph those two equations right now. So I assume you guys have them graphed now. We have 8e to the 2x equals 20. We've graphed both of these. Now notice this is a 10. This is a 10 by negative 10, right? 10 down to negative 10, negative 10 to 10. So which one of these isn't going to be on there?
Y equals 20.
Y equals 20. That's way up. Maybe it's way up here.
It's double the height.
Okay, so we've got to go and adjust our window. So let's change our window settings. Let's make our y max greater than 20. So if we move it up to 25, that would probably work. And then if we graph them, we end up with something that looks like that. Now, what is this point called? That's our point of intersection. What else can we call it? It can be called our solution, right? Where those two things intersect, that's our solution. It's like you have a system right there. Okay? So from there, if you calculate the intersection of the lines, let's go ahead and use our calculate feature. We know what y is going to be. It's 20 all the time. What we want to do is find x. Make sure your x matches my x. You're doing it right. Cool. How many got it? Okay. Hey, any questions on it? Okay, so we now know how to use our calculator solve. Let's actually go to example 3. Okay, questions 8A and B. Let's do some of these problems, see if we can get them down. Understand how to work through them without our calculator. Okay, so technically right now, you guys know how to solve this on your calculator. Y sub 1, Y sub 2, graph them, good. Okay, that's not the efficient way to go. We want to learn algebraically how to solve it. So, first step. What are we going to do first there? Noel?
Subtract 7.2.
Good, let's subtract 7.2. All right. Get e to the 2x over 5 power is equal to 1.9. Tell your neighbor the second step, please.
We have to take.
Good. Volunteer. Second step. Yep.
Put it into log form.
Yeah, the variable's in the exponent, right? So if the variable's in the exponent, go to log form. So our base is going to be base
1.9.
Uh-oh.
1.9.
So many of you will think, hey, this piece moves over, right? That's log base e of 1.9 is equal to
2x over 5.
2x over 5. Now, log base e is the same thing as what? Natural log. So that's where that's coming into play. So it's the same stuff we've been doing, it's just that's natural log now. Okay? And there is a natural log button on your calculator. Everyone find that one.
Found it.
Okay? Very good. So, right here, this is a proportion, correct?
C.
Right? Cross multiply and divide, or just multiply both sides by 5. We get 2x is equal to 5 times natural log of 1.9.
3.21.
Oh, sorry.
Approximately 3.21.
Thank you. 5 times natural log of 1.9. What's the next step?
Divide by 2.
Yeah. Divide by 2.
Approximately 1.6.
Okay? So notice I haven't put it into my calculator yet. This point is where I'm putting this part in. No addition signs or subtraction signs in the top. So if you just write it as 5 ln 1.9 and then hit divided by 2, that should give you your solution of
1.6.
1.6. All right. Okay, now let's round that to the nearest. What's your assignment say today? Does it give us a rounding point? Okay, if not, let's go to the nearest hundredth on that.
Yep.
Okay. 1.6.
It's 0.4, but
0.4. So okay. 1.60. All right. Okay. Very good. All right. Hey, I want you to go ahead and try 8B. Try 8B now. Yeah, there's 8B, so you can see it. But. Okay. Hey, let's go ahead and go through this. What's the first step?
Plus 5.
Yeah, let's add 5. Let's get rid of that 5 first. Okay, add 5 to both sides. We get the natural log of x plus 2 over 3 is equal to 12. Next step.
Put it in exponential form.
Why do we go to exponential form? Someone else? Hubert?
Because that way it gets the variable out of the log.
Good. It gets the variable out of the log. So we move that. We go x plus 2 over 3 then is equal to, we bring that ln over, it makes it
E to the power of 12.
good. That's e to the 12th because the natural log, remember, natural log is log base e. Okay? So that brings that e over, that base becomes e to the 12th. All right? So, it's a proportion again, right?
Yep.
And cross multiply, it gives us x plus 2. Okay, we get 3e to the 12. Now what? Crook?
We get the variable by itself by subtracting 2.
Good. Subtract 2e, 3e to the 12 minus 2. That's where we throw it into our calculator to get our approximately.
488,262.37.
Holy cow.
Approximate.
Yeah, who got it right? Hey, well done. All right. Any questions? Some good work out there. Okay, we want to move on to the mixed side of your assignment. So if you look at number 41, there are 3 problems I want to do with you. Okay? Let's look at 41, copy it into our notes, and 42, and you can even get 43 in your notes if you want. But give yourself some. These problems can go really quick if you know some different rules here, or you can recognize some things, I guess. Log base, or natural log of e to the 2x, let's write that, use the product property, and bring that 2x over. Okay? So this part jumps out here. This part, natural log of e is what?
1.
1. So we get 2x equals
44.
44, or x is
22.
22. So anytime you see natural log of e, remember that's 1. That makes it really easy. Okay? It's equal to the number 1. Questions there? On to 42. Notice you have that e and ln by each other again, right? Right now, if we're doing this one, we have this part here, the variables in the exponent. I know it looks weird, but it's up in the exponent spot. So we're going to write this. We're going to bring that ln 2x out by writing it as a log. And I know there's a log up here, but this part's not the log. So we're going to bring that over. That's log base e, or natural log of 44. Well, if the natural log of 44 has to equal the natural log of 2x, then really 2x has to equal what?
44.
44. So x is
22.
22. So really this part you can kind of ignore, and this becomes 2x equals 44. I know that seems weird. Mathematically this is why it works. Okay. Any questions there?
Could we do more?
Yeah, we can. All right, there is number 43. I want you to give yourself a minute to work on that. So here we go.
Oh no.
You get natural log of e, okay, or e to the natural log of x, excuse me, plus ln e to the 3x plus e to the ln 8. Okay, so if we're going through this part right here, let's apply the power property. That gives us 3x ln e, and we'll just bring this piece down, e to the ln x, and that is equal to e to ln 8, right? This part right here gives us what? 1. All right, so we get e ln x plus 3x equals e ln 8. All right? Now from there, note that if we take this, and let's just kind of treat it as a separate problem for a minute. If, let's say that e ln 8 equaled y. You guys with me?
Yeah.
We're just doing a separate problem. Okay? If that was true, that would mean ln 8 equals ln y. Is that correct?
True.
And we bring this e over and write it as a log. So what does y equal?
8.
Yeah, this whole thing equals 8. Okay? Because the e and ln, they kind of cancel each other out. And so if that's the case, what's this whole thing equal?
X.
X.
X plus 2.
X plus 3x equals 8. 4x equals 8. So x equals
2.
2.
I did it wrong. I did it wrong.
Cool, right?
I got the right answer.
Hey, questions? So really, anytime you see e and ln right next to each other, it's like having the number
1.
1. Okay. Very good. That's it.